Ever see those images of hurricanes swirling across the ocean, like massive storms that just seem to appear out of nowhere?
Oh,
How do those even form? Well, that's what we're diving into today.
yeah.
We're taking a deep dive into the science of hurricanes, and we've got some really cool excerpts from the National Ocean Service, NOAA,
All right.
to help us break this all down.
That was good.
So it turns out that the recipe for a hurricane, like the basic ingredients, are actually kind of deceptively simple. You ready for this?
I'm ready. Lay it on me.
Warm ocean water
Okay.
plus thunderstorms.
Hmm.
And that's kind of it. Sounds like, a regular summer day in some places,
Right,
right?
right. But, and this is important, it's all about the specific combination of those ingredients and the scale. It's not just a matter of, oh, it's a little warm and stormy, must be a hurricane. It's way more complex than that.
Okay, yeah, that makes sense.
Yeah.
So, like, how do we go from some warm ocean water and a few thunderstorms to this massive, like, swirling storm of epic proportions?
Okay, so picture this. The sun is beating down on the ocean, right? Heats up the surface of the water. And all that warm water, it evaporates. But here's the thing, it doesn't just disappear, it carries a surprising amount of energy with it as it rises.
Okay.
And we call that stored energy, latent heat. Think of it like, I don't know, a battery, just waiting to be tapped.
So the ocean is literally fueling the storm from below.
Exactly. And as that warm, moist air rises,
Mm-hmm.
what happens? It cools. And all that water vapor that was being held in the air, it condenses back into liquid, forming clouds and thunderstorms. Now, here's where the real magic happens. Here's where the swirling comes in.
Okay, I'm ready.
So as more and more warm air rushes in to replace the air that's rising, this whole system,
Yeah.
it starts to rotate, and that creates a low-pressure center.
Kind of like water going down a drain?
Yes,
Yep.
exactly. That's a great way to think about it. And this whole process, it just feeds itself. More warm air rises, more condensation happens, the winds get stronger, the pressure drops even lower, and bam, you've got yourself a hurricane.
Wow. And I mean, we hear about how powerful these things are, but I don't think people realize, like, the amount of energy involved. It's unbelievable.
Oh, absolutely.
Yeah.
You know, the research we are looking at, it actually said that a hurricane can generate more energy than the entire world uses in electricity.
That is wild. I mean, we're talking about enough energy to power New York City for, what, years?
Yes, decades.
Decades. It's really mind-boggling when you think about it.
So we talked about warm ocean water and how crucial that is, but are there any other factors that kind of play into this whole hurricane forming process?
Oh, absolutely. You can't discount the atmosphere. There are things like wind shear. Wind shear is basically a change in wind speed or direction at different altitudes. And if the wind shear is too strong, it can actually rip a developing hurricane apart.
So it's this delicate balance almost of all
Yeah.
these different elements.
Exactly. That's a great way to put it. It really just goes to show you how complex and interconnected these weather systems really are. So we've covered a lot of ground here. We've talked about how hurricanes form from those first like plumes of warm air rising off the ocean to those massive swirling storms we see on the news.
It's incredible.
What's like the most important thing you want our listener to take away from all this?
You know, I think the key takeaway here is the incredible power of a hurricane
Hmm.
and the really, really crucial role that warm ocean water plays in fueling these storms. But, and this is something I was thinking about earlier, you know, with climate change and the fact that ocean temperatures are continuing to rise, we could see even more intense hurricanes in the future.
Yeah.
Something to think about.
Definitely something to think about.